So here we have g of x is 1 over x squared plus 9. We want to find g prime of x and g double prime of x. I'm going to choose to use the chain rule here. So one of our versions of the chain rule is that dy dx equals dy du times du dx. So instead of writing g of x, I'm going to write it as y equals 1 over x squared plus 9. And I'm going to say that g prime of x then is the same as dy dx. Why am I doing this? Because I want to use this rule here. And u is typically going to be the inside function. So u is going to be x squared plus 9. Du dx is the derivative with respect to x of u. The derivative with respect to x of x squared plus 9 is just 2x. If that's the case, what is y then? Y is 1 over u, which is the same as u to the negative 1 power. So what is dy du? What is the derivative of y with respect to u? That's negative 1 u to the negative 2. So making those substitutions then, dy dx is dy du times du dx. What does that give me? Dy du, which is negative 1 u to the negative 2, times du dx times 2x. What does that mean? G prime of x is negative 1 over u squared times 2x. But what is u? What was u? U was x squared plus 9. So we say g prime of x is negative 1 over u squared, x squared plus 9 squared times 2x, which will give me negative 2x over x squared plus 9 squared. So that is the more formal version of using the chain rule, recognizing this fact that dy dx is dy du times du dx. Now let's take an alternate approach, do it a slightly different way. This time we have g of x is 1 over x squared plus 9, which is x squared plus 9 to the negative 1 power. We want to do g prime of x using the chain rule. G prime of x is the derivative of that, the derivative with respect to x of x squared plus 9 to the negative 1 power. And here's how we think of that. The derivative with respect to x of something to the negative 1 power. What is that? We remember our power rule. The derivative with respect to x of x to the n is nx to the n minus 1. So what this becomes, the derivative of something to the negative 1 is negative 1 times this something, decrease the exponent by 1, negative 1 minus 1 is negative 2 times the derivative of this something. But what is the something here? The something here is x squared plus 9. So it's negative 1 x squared plus 9 to the negative 2 times the derivative of x squared plus 9, derivative with respect to x. What do we get? G prime of x is negative 1 times 1 over x squared plus 9 squared times 2x. What does that give me? G prime of x negative 1 over 1 times 1 over that times 2x negative 2x over x squared plus 9 squared, which is what we had obtained using the other approach. Now, let's go ahead and check this on Desmos. We had our original function, and then we are going to check to see what its derivative is. So our original function here was 1 over x squared plus 9. Let's go to Desmos. And we call this function g. G of x is 1 over x squared plus 9. And how can we have it just graph the derivative? The derivative is the limit as h goes to 0 of f of x plus h minus f of x over h. So let's remember that fact, right? So g prime of x equals the limit as h goes to 0 of g of x plus h minus g of x over h. So my concept here is going to be use a small h to graph this. So an approximate graph should be acceptable if I go with a small enough h. So what I'm going to do is I'm going to take, okay, we'll call this k of x equals g of x plus h, g of x plus h minus g of x all divided by h, except I need a small h. So let me use an h of 0.001. Use a small h of 0.001, and there's our graph. So this graph's not very good. Let's go ahead and zoom this in. Whoops. So, and still not great. So I'm going to go ahead and see if I can identify this. So I need to have very, very little y values on my graph. So maybe minus 0.2 to 0.2. Now we can see things. All right, so the red graph is my original function. The blue one is what I think the derivative is. So here is the graph that I think is the derivative of my original function g. Now I computed it on the paper, and we thought the derivative was negative 2x over x squared plus 9 squared. Let's see if it matches. So I have that k of x. Let me call this p of x. What I believe the derivative is negative 2x divided by x squared plus 9 squared. And we'll turn off red and blue. Does the green graph match what I had for k of x? Let's turn this off, and this is what we thought it's supposed to be. There's the blue graph, there's the green graph, and they seem to match. So I feel pretty good about my computation here. That what I computed using the chain rule was the same thing I get by using a small h with g of x plus h minus g of x over h. Okay, so we have the derivative. Now we want to get the second derivative. So g prime of x is negative 2x over x squared plus 9 squared. G prime of x is negative 2x over x squared plus 9 squared. And I want to get a second derivative. The second derivative, g double prime of x, is the derivative with respect to x of g prime of x. So g double prime of x is the derivative with respect to x of negative 2x over x squared plus 9 squared. And how are we going to do this? We're going to use the quotient rule. Let's remind ourselves of the quotient rule. U over v prime is u prime v minus uv prime over v squared. So what is u here? What is v? U is the numerator, u is negative 2x. So u prime, the derivative of negative 2x is negative 2. What is v? V is x squared plus 9 squared. So to do this, we need to use the chain rule again. So v prime is the derivative with respect to x of that thing squared. V prime is the derivative of x squared plus 9 squared. So what is the derivative of something squared? V prime again is the derivative of something squared. Well, what is that? That's going to be 2 times the something to the first. Pull the exponent down. 2 times something to the first times the derivative of the something. 2 times the something to the first. What is the something? What's going in here is x squared plus 9 So it's 2 times x squared plus 9 to the first times the derivative of x squared plus 9. So we get 2 times x squared plus 9 times the derivative of x squared plus 9 is 2x. So we get v prime is 2 times 2x, 4x times x squared plus 9. Now, what is my g double prime of x? G double prime of x is u prime v minus uv prime over v squared. So g double prime of x, u prime v, u prime, what is u prime? Negative 2 times v, what is v? U prime v, v is x squared plus 9 squared. Minus u, what is u? U is negative 2x. So u prime v minus u, v prime, what is v prime? So we have that 4x times x squared plus 9. All over v squared, and this is pretty nasty looking. V squared, what is v? V is x squared plus 9 squared, so v squared would be x squared plus 9 squared squared, or x squared plus 9 to the 4th power. So that's correct. It's obviously not simplified, but that should be the correct answer, although, of course, we will check it on Desmos here shortly. So let us see if we can simplify this a little bit. Where are we at currently? We are at g double prime of x is negative 2 times x squared plus 9 squared minus negative 2x times 4x times x squared plus 9, all divided by x squared plus 9 to the 4. So the algebra here gets a little tricky. I'm not going to distribute. I'm going to leave it alone so that we can get things to cancel. Divide out. Negative 2 times x squared plus 9 squared. Minus a negative, it'll become plus. And I have 2x times 4x. That 2x times 4x is 8x squared times x squared plus 9 over x squared plus 9 to the 4. And you'll notice that we have a lot of x squared plus 9s here. So let's factor the x squared plus 9 out of the numerator. Factoring out the x squared plus 9. Out of the first piece, what do I get? Negative 2 and then another x squared plus 9 to the 1st power. Plus factoring an x squared plus 9 out of this piece, I get 8x squared. Then divided by x squared plus 9 to the 4th. This is to the 1st power, that's to the 4th power. That will divide out and give me x squared plus 9 to the 3rd power downstairs. So upstairs, we just have this parentheses. So negative 2 times x squared plus 9 plus 8x squared divided by x squared plus 9 to the 4th. Again, so x to the 3rd. 1 upstairs, 4 downstairs. Now we're left with 3 downstairs. So let's distribute now. So that gives me negative 2x squared. Negative 2 times 9 is what is minus 18 plus 8x squared divided by x squared plus 9 to the 3rd. And where does that put us? G double prime of x. 8x squared minus 2x squared is 6. X squared minus 18, which you could factor out a 6 if you want, but I don't really need to. Divided by x squared plus 9 to the 3rd power. And we believe that this is the derivative of the derivative. So I want to check this on Desmos. So let's go back to Desmos. So my derivative was p of x. So what would the derivative of p of x be? We'll turn everything off. the derivative of p of x, which I'll call q of x for now, would be p of x plus h minus p of x over h. So p of x plus a small number minus p of x divided by that same small number. And this is what we think the derivative is. So the derivative of the derivative, I believe q of x is the second derivative. Now, let me turn that off. What did we compute it to be? We believe the second derivative was 6x squared minus 18 over x squared plus 9 cubed. So let's type that in. I don't know what letter I'm up to here. I use K, P, and Q. Let's call it W of x equals 6x squared minus 18. I'm going to divide that by x squared plus 9 to the third power. The question is, do these last two things match? This black function, that's what I believe the derivative is. And then I compute it with a small h here. This is the blue function. Do they match? They sure do.